Good evening, everyone. I'm John Stout, the airport manager, and I want to welcome you tonight to the Airport Approach Feasibility Study. This is our second outreach meeting. We had one last fall. We do have the agenda up on the screen for you tonight. We're going to start out with an introduction by 5th District Supervisor Linda Hopkins, and then we'll get into the presentation and go over where we're at in the study, what we've come up with in terms of conceptual procedures, and then we'll finish this part of the presentation and go to the workshop where we can interact one-on-one with Cignus and the consultant team on specific boards and answer your questions. And with that, I'd like to bring up Supervisor Hopkins.
Good evening, everybody. And I have to say that it's lovely to be in a cool space right now because outside it feels like a little bit of an oven. I'm going to jump right to the point, which is that we are here because you all don't like airport noise, airplane noise, disturbing your, peace and quiet in West County, and neither do I. And yet some of the challenges are that we actually have a very limited scope of control over what planes do when they're in the air. And we are attempting actually to change that through this process. I want to also say up front, though, that what we are talking about right now is the arrival pattern, right? And we are getting a lot of complaints right now that are associated with departures. And something happened that this county wasn't actually even notified about. And we actually learned when we started getting complaints from folks who were impacted by it, which is that the FAA actually made a decision known as the redhead decision that allows commercial flights to actually turn west over Western Sonoma County from the airport at a height of only 500 feet. That is very low. It is very, very loud, right? Especially since they're really utilizing quite a bit of power as they're taking off and as they're turning. And so right now what we are talking about is arrivals, but there will be a subsequent process that talks about departures. So never fear, it's just going to take us a little while. We're about a year into the process of the arrivals side, and the departure will be coming at a future date. And so we do hope to, again, push back on that decision and actually require a higher height out of the airport. But ultimately, this does have to be approved by the FAA. And I just also want to give a little bit of context, which is that I do serve on a couple of different regional boards and commissions, and we in Sonoma County are like the tiny backwater to the Metro Bay Area. And so when the FAA is making decisions, they are really truly prioritizing the international airports, right? SFO, San Jose, Oakland, and we end up kind of taking a back seat to those broader flight patterns, which in this case has, especially for those departures, really pushed, unfortunately, a much lower height for those takeoffs. So I just want to know that I hear your frustration. I am frustrated as well. It's very frustrating when you have a federal agency making decisions that directly impact us without even telling us, let alone actually asking us our opinion about this. But we are working on different strategies to mitigate noise because, I've read all of the studies that I'm guessing you have in terms of mental health and sleep and the sort of impacts of that, noise interruption from aircraft. And we really are trying to do our best to mitigate that. So without further ado, I'm going to hand it back to John, and I think he's going to introduce our consultant team. Thanks, everybody, and thanks for being here.
All right, if you can switch to the presentation slide deck, please. And since this is set up as a webinar as well, we do have participants participating on Zoom. So we will be showing closed captioning and trying to have that information available to those that are not able to be physically here tonight. Next slide. So the presentation is a workshop format. We'll be doing a presentation going over the materials. This is not an interactive Q&A session. The Q&A will be in the workshop session. And we'll be going over I'll introduce the project team, the meeting format, background and objectives, the study objectives, what are the project tasks that we've done and still have yet to do, the project design approach, getting into the limiting factors of how the FAA will let us design a procedure, Most importantly for you is the conceptual designs that Cignus has come up with that they've worked with the FAA on. And we still get questions on why are we not doing a Part 150 study. So we'll cover that a little bit more detail. And then finally wrap up with a fly quiet program discussion. Next slide. So I'm John Stout, the airport manager, and tonight we have Vinny Cajera, the project manager with Cignus. I'm not going to go through their bios, so keep that part short. Jeffrey Cochran and Patty Daniel. So you'll see them, they have a yellow name tag. So if you have technical questions, they'll be in the workshop area. Look for the yellow tags. And then airport staff has one that says airport staff, and we'll be also happy to help. Next slide. The presentation itself should take about 45 minutes. Again, it's a webinar format. We do have participants online, and we'll be doing it as a workshop. We have 4 stations set up just to the right of where you came in with all the boards for the procedures with the overlays, 1 station set up with a computer display. So if there's documents you would like to see that we have in our study materials, we can pull them up. Go through the current conditions, recap of last year, and review of the procedures and how they changed with what we're proposing. And from there, really get into, Jeff will spend a lot of time going through the conceptual procedures, and those have been preliminary reviewed with the FAA. And we needed that feedback because we don't want to present something to you that the FAA is unlikely to approve. And at this point, they're on board with the concepts. So that greatly increases our chances of moving forward. And the feedback is extremely important. And we are doing it slightly different than you see in some workshops. We do have a court reporter in the room directly behind the theater. We want them on the record so we can have them verbatim, and we're going to aggregate all those comments. Every comment will be responded to. They'll be published on our Good Neighbor website, both the questions and the responses. There's a QR code that's available. We printed up cards, so if you'd like to take this with you tonight and you think of a question down the road, scan the QR code and it'll take you to the website to put in a comment. Comments will be available to be taken until October 20th, and everything will be addressed in a formal format. I also like to point out, it's a little confusing. We call it a study, but it's not like a typical study where there's going to be a thick document that says study results. Study is really focusing on the procedures, and the outcome is a draft procedure. There'll be materials from meetings like this, the documentation that we've been presenting. We'll bind that all into one package, but it's not going to be a typical bound study document. Next slide. On the why. Next slide. Uh-oh. We tried it 4 times, really. Why we're doing the study? We hear your concerns. The FAA changed procedures approximately 3 years ago. That was the first change that they did in the Oakland Center airspace that impacted us. Shifted flights more over Sebastopol, Forestville. You see them on the approach to our going to the north to land on our main runway. This process is really the only way to get the FAA to change our procedures. The FAA, as Supervisor Hopkins stated, the FAA looks at the larger areas first. We're secondary. The FAA has a lot of procedures in their queue that they're working on, and we're not a real high priority. So if we left it up to the FAA to change it based on your feedback and commentary, it'll take a very long time for them to actually get to it. So with this, we can cut a lot of time out. It's still going to take a fair amount of time to get to it, but it's the best way and fastest way to make a change. It's important to us in a material investment. The airport is investing a fair amount of money to get this procedure done. We've hired consultants that have part of their team certified and recognized procedure change design companies. There's only 6 firms in the US allowed by the FAA to design procedures, and 2 of them are on part of this team. So the focus tonight is to present the conceptual procedures, get your comments, but at the end of the day, we want to be a good neighbor. We want to address the noise. And we also want you to understand the process. And it's controlled by the FAA. Once the wheels leave the pavement, the airport does not have control. And we have to follow their process and procedures if we want to get a change. And again, going through the draft presentations and receive constructive input. And with that, I'd like to turn it over to Vinny.
Thank you, John. So as John mentioned, we're here to present the conceptual designs that we've been able to come up with working cohesively with the FAA. So how do we get about to that? Jeff will talk a little bit more about it. But to get to procedure design, we always have to have a study objective. And as John mentioned, it's about bringing positive change, effective positive change. And that is by working cohesively and hand in hand with the FAA, understanding the environment that we're working with, hearing your concerns, and bringing those also to the FAA so that the designs that we come up with are, I would say, cohesive. They're done in concert with the FAA. That way the buy-in with the FAA is easier. The process will be a little shorter, and it will hopefully get implemented here in the near term. And we're still working on the timelines, and we'll get into that a little bit later. Next slide, please. Talking about the FAA and working with the FAA, this is the mandated process that the FAA goes through when they're designing procedures. We as consultants are following that process down to the T. Why? Because when we turn these over to the FAA for implementation and consideration, they have faith that we followed their process. They will go through this on their own again, but it is going to be quicker, faster, and hopefully more efficient as they review these procedures. Next slide, please. As I mentioned, Jeff Cochran will be coming up here in a second to present to you the details of the design. How do we get to it? What do we take into consideration? But at a high level, how did we start the process? It's by listening to you, listening to your concerns. We had about 50 plus comments from the first meeting. We went through all of them. And to the extent possible, we took those into consideration during our meetings with the FAA, where we presented conceptual designs and got feedback from the FAA. And obviously, John, also, as he mentioned, your concerns are paramount. And so with that, I'm going to turn it over to Jeff, who is going to go through the detailed process of why this approach is effective and how we believe the implementation consideration by the FAA is going to reduce the timeline for hopefully implementing these procedures, whether they're 1 or 3 or 4, we don't know yet, but we're going to get to that in a minute. Jeff.
Thank you, Vinny. So Supervisor Hopkins and John have already talked to you a bit about the process. One of the things I guess I can refer to by starting is when we talk about the FAA, it isn't a person, obviously. The FAA is a huge administration. Their primary goal is safety oversight and efficiency. So if we go to the next slide, this sort of spaghetti network that you see, we're looking at departures, arrivals that are coming into the Bay Area. It's been mentioned that we make up a fraction of the traffic in that overall network. If you look at the complexity of the networks, the Northern California airspace is about the 3rd busiest in the nation, just behind Los Angeles and New York. So it is a busy airspace. It has to be connected. And a lot of the things that we'll see in what we followed for the process is to try and make sure that when we are talking to those components of the Federal Aviation Administration, that they see that this is a benefit for them in connecting to their network, and we are getting what we need for our local residents here around this airport. So before I move off this slide and go to the next one, the type of control is also distributed amongst the areas of the FAA, and it's important to sort of visualize what's referred to as an inverted wedding cake. We've got circles of control that sit on top of each other. Perhaps another way of looking at it would be like a water tower. You see the single core going up, that might be what's around your airport. The big disc on top, that's the airspace that sits over top of that. So this is the kind of structure that we're looking at in the airspace. If you go to the next slide, you can see that it gets quite busy. And it's not just about airplanes coming in, but it's airplanes that are overflying, going into the Bay Area. They are coming out. They are doing overflights. So this is what we have to connect to. We have to connect these off ramps for the procedures. So we'll see how we've tied those in these slides that will follow. Next slide, please. This is a list of acronyms that list out the procedures. If you're interested in going on the internet and seeing what pilots look at and what is provided to them, it's important to also know that these procedures have to be published. They have to be in the public domain. And this is how you meet the legal requirements for the airlines and others who are using the procedures to be able to put them into their aircraft, into their flight management systems, and utilize them. So we can't just draw pictures and have them get out there and have the aircraft flying them. So this will become very important as we start looking at the departures as well. Next slide. So some of the things that became available to us to make this possible, these enablers. And you might ask, well, why is this important to me? I just want to know whether it's going to be noisy over my house. Where are these tracks going? By knowing what it is we use to build these procedures, it helps you understand better what might be possible for change, both for the coming departures and what we looked at in building the arrivals. So trying to get this common understanding, the first bullet point there, the new navigation technology supporting higher precision and predictable paths. We have what's called area navigation and required navigation procedures. These allow us to take those little boxes that you see around the center line on these diagrams at the bottom and basically make them smaller. And by doing this, we can better control where we put the paths over the ground. So it gives us more flexibility in where we can have the aircraft fly. This is an advantage for us. The same is tied into the accuracy of the airplane being able to stay on the center line of this new line. By having all of these tools at our disposal, we have a greater flexibility as to where the paths can go and how we can work with the FAA to make sure that we connect those off ramps that I showed you earlier, and we'll get into a little more detail, that they will like what they see and it will be the best all-around solution for everybody. The new procedures are also going to be linked to the en route departures or the en route network. And you'll see the importance of this as I go to the next slide and thereafter. So if we go to the next slide, in particular, coming from the en route, we have a descent that we have to make. And we can either do that as it's shown on the bottom with this sort of stepped descent, we call it an unstabilized descent, or we can do the one that's indicated on the top graphic. We obviously would prefer the top graphic, and the reason being is multiple fold. One, if an airplane is descending at a constant rate, they can set one power setting, a low power setting, emit less noise. Every time one of these airplanes levels off, as you can see in the lower diagram, power up, it gets louder. You not only notice that it's louder, but you notice the change in the noise level. So the background noise is actually, it's not just its magnitude, but it's the annoyance factor. The amount that it changes. So these are some of the things that we are building into the procedures to make sure that we avoid making more noise. In addition, when you level off and you're down low, you have more drag. The air is more dense, we're using more power. And if we're using more power and burning more fuel, we also have greater greenhouse gas emissions. So there's multiple things that we can accomplish just by managing that vertical profile and having a nice continuous descent. You can go to the next slide, please. So now let's start talking about some of the specifics. Starting with runway 14, in this picture, this is a two-dimensional top-down view of the paths that currently exist, the yellowish paths coming down from the north, and those that we have proposed connecting to the en route. The first thing you'll notice from what is there today is that there are more ways to enter this procedure. The original path has basically a Y at the top with 2 points to enter. Whereas with the revised positions, we can come straight in from the north and from the east, south, or coming out from the west. We've got a defined path that brings you further from the airport and into a position to line up on final. Now, I know that slide is fairly zoomed out. So I'm going to go to the next slide and show you exactly where they start. So we're reaching well back into the en route structure. And we want to do this because we want to capture the airplane at its top of descent, 15,000 feet above ground, and have it do this continuous descent all the way down and around. We do not want it to descend to 5,000 or 6,000 feet, power up, as you saw in that previous slide, make lots of noise, burn lots of gas, and fly over your homes. So what we're trying to do here is reach this stabilized continuous descent. But to do that, as has been pointed out on the next slide, it'll show you how it connects into the network. Kind of hard to see on this graphic. The black lines that are in the background are all of the low-level airway networks, if you want. They're the highways in the sky that the airplanes are going to be on for the most part. And we've tried to draw this purple line. And if you can't see it here, don't worry about it. We do have it reproduced on boards section. So you'll be able to see it there along with the expected altitudes of the aircraft. But you can see this is how we have to connect. And this is how we get the buy-in by the Federal Aviation Administration, by building it, connecting to their route. And then we can tweak what happens down low as we get in closer to the airport. So the next slide shows you, as we start coming down, some of the things that are improvements in this design. If you notice the teal line going to the west, we're further from the airport. Instead of, I'll give you some scale first. The circle, the yellow circle that's around the airport is 5 miles in radius, so that's 10 miles in total across. So what we've done is we have created a defined path that air traffic controllers can put an aircraft on, as opposed to not having them in the previous design in the yellow lines that you see. Air traffic control would provide a heading and an altitude. And that heading could go as close to the airport as they deem appropriate. It might be right on the edge of that 5-mile ring, and bring them around close in tight and have them land. So flying over more built up areas and flying down low, because when you're doing what's called these radar vectors, that's what they're referred to because they're looking to them on a radar screen and giving them a vector to fly. When they assign these, they want to get them out of their hair. FAA high-level controllers, they want to get the traffic out of their way, off the highway, out of the way of the other airplanes, so that they don't have to worry about managing multiple airplane interactions. It is safer to get them out of the way. This is a way to get them safely out of the way and still manage the descent profile. So we're trying to get rid of those vectors. This way, they'll follow those defined paths. You'll see on the boards that it's going to be quite a high altitude at the bottom, and still coming by the airport, you should be anywhere around 9,000 or 10,000 feet as you're coming past, as opposed to 5,000 feet driving level. So we're managing that vertical better for you as well. If you go to the next slide, we've zoomed in again. This is once you've come around the corner and you're lining up for final. On the left-hand side, we've got this convergence point. And all these procedures, you'll find this is common. At about 10 miles from the airport, from the perspective of safety and efficiency, the aircraft should be aligned as much as possible with the extended runway center line. So we want them lined up. They should be configuring for landing. They should have a set power setting, and they should be on this continuous descent profile. The previous or the existing procedure has a bit of a dog leg in it. This was, and you can see as we get in closer to the airport on the right-hand side, the runway down here, there's quite a change in the angle of approach for the aircraft to line up onto the runway. This is not ideal, both from the perspective of safety of flight. Pilots don't like to have to be doing maneuvers down low. And if you're maneuvering, you are increasing power legs. Because every time you bank an airplane, you increase its drag, power comes up, more noise. Let's get them on this continuous descent. That is the objective. Are you coming to change the batteries? I'll pause for a moment. Okay, we are broadcasting this on a webinar, so I'm going to try and use the pointer. I didn't use it before, but we'll see if it shows up on the broadcast as well. It'll help to point out what I'm referring to. So, original procedure, our proposal. Now, we're trying to line up with the runway center line. And the difference in the current noise exposure is that airplanes didn't really stay over here anyway. What they do is this extended runway center line, this red line here, is what everybody tries to line up on. So if you were flying the original procedure, you come down here and say, oh, I have the runway in sight. So what do? They step over here. Oh, someone's drawing arrows for me. They step over here and they fly on this red line. So they actually will bank the aircraft, bank again, and now they're flying down this line. What we've tried to do is build a procedure that still allows that continuous descent. You're lined up with the runway, and it's offset by 3 degrees, and it tries to avoid overflight of Healdsburg. So we're trying to, as much as possible. If you bend it any more than this, you'll get that same sort of reaction where they just won't use the procedure. They'll end up flying a maneuver that puts them where we can't predict and where we can't manage that vertical. So this line would be really the line that you would expect today being flown. And this is the line, this teal line is the line that we would expect to be flown when these procedures are published, because there's no incentive now for the aircraft to maneuver off of it. They've got all the indications in the cockpit to safely follow that line in descent. If you go to the next slide, we've taken that same picture and overlaid it on a satellite image. And just to summarize the kinds of things that we're doing, the straight in, more or less straight in, as opposed to this offset that was at 15 degrees from the runway center line, this should lower the overall noise footprint. It should lower, therefore, the greenhouse gas emissions. In addition, what we've done is we've taken the altitude at this point and we've raised it slightly to make this a slightly steeper descent angle. And if you're at a steeple descent angle, it's just like rolling down a hill. You don't need as much power on the aircraft. So again, we're trying to mitigate the noise footprint that the aircraft makes while it's on descent, because we do have to, at some point, be lined up with that center line as much as possible. And our design criteria allows us to call up to 3 degrees offset, still straight in from the perspective of all of the safety aspects that are required from the management of the aircraft and the flight management systems. Okay, I think I covered all of the ones for 14 that I wanted to mention. So if we move on to the next slide, we can start looking at what we were looking at for runway 32. Again, there's a whole bunch of lines on here that may be a little confusing. I'll give you some perspective. This is the 5 miles around the airport. This is our extended runway center line. And the blue lines in this case are all of the connections that we're proposing to bring aircraft in and line them up on this extended center line. We have slightly less flexibility in the design for runway 32 because this little colored fan section that you see here, this is the instrument landing system, and it's actually a path that's broadcast from the ground. So they have to be within the area of this fan. The aircraft must be within the area of this fan before they can start descending towards the runway. What we have done is we've made connections so that aircraft coming from the north will be further
and higher from the airport as they come down, doing this continuous descent and come around the corner. They will not be vectored by air traffic control to cut close and turn in tight. And because they are going to start out here, even if they see the airport, they will not want to cut in and overfly these other areas because they need this distance to lose the altitude that they're at. So by design, we're making sure as much as possible that what we put out there will actually be flown. So if we go to the next slide, there's a little bit of more detail. Of the connection points. Down here, these connect to the standard arrival routings that come out of the Oakland area. So we pick up these points. We're at, I think we're around 8,000 or 10,000 feet out here, and in that continuous descent. The next slide is going to show the zoomed in detail. This is that instrument landing area that I spoke to, and these are the proposed lines that we have added to the procedure to allow a transition to get to this final. If you don't have these, there's no real sense of, from the aircraft's perspective or air traffic's perspective, how far do I have to fly in order to lose the altitude that I have? So they'll tend to, if they're brought in closer on a radar vector, they'll tend to get as low as possible, as soon as possible, so they don't get caught in a position where they can't land from the procedure. So there's a good reason for building this structure. So then if you go to the next slide, you see a summary of what we've done here. Reducing the flights over residential or built-up areas by having this transition from the north, keeping you further away from Sebastopol. You're going to be out here at a high altitude, somewhere around 10,000, 11,000 feet, and descending as you come down and around the corner. You will have to be at a 10 miles. You're at about 3,000 feet for a normal descent. So you're at this point, you will be doing your standard final approach segment. So that's one of the key aspects of that. The anchor points that we have here to the en route, I've mentioned both the arrival routings and other various navigation aids that air traffic need in order to know exactly where the airplane is when they're transitioning for the descent. That reduced noise footprint is going to be translated anywhere along these paths, as opposed to bringing them in to these areas down low and making more noise and burning more gas. So that's 32. If we look at runway 02, next slide. Now let's keep in mind that runway 02 is a shorter runway. It is not the preferred runway for large air carrier type aircraft. They need more distance for landing, for taking off. Also in poor weather conditions, it's not the preferred runway because it has different lighting systems. There's all sorts of reasons why this is mostly a general aviation visual type of runway. The main difference you can see here, the blue lines are the ones we are proposing. Lots of connections to the en route, as mentioned before. The standard arrival routings come in at these points, as opposed to these yellow lines where the original procedure basically had 2 points to start from. And as a pilot myself, if I was coming up from the south, the last thing I want to do is fly way over here in order to come back in. So I would probably be looking to overfly all of your homes if I did not have these procedures. So ideally, the handoff will come, the aircraft will follow these lines, they will do a continuous descent, and as mentioned in the previous designs, at about 10 miles final from the runway, we have to start that final approach segment, and that path is going to be common for each of those runways. Not a lot of flexibility as to what you can do at that point. The next slide, just if you can go to the next slide, just shows it without the existing procedures. thing I will point out on the next slide, if you would, please. I've zoomed in here at that point where that 10-mile final starts. So we concentrate the aircraft coming in because from a safety perspective, there are things that change in the cockpit from a sensing and display as far as obstacles and obstacle clearance. So we have to pick this point at that distance from the runway in order to start making sure that the airplanes come there, converge at that point, and then they start to descend. Again, this is a low utilization runway. Okay. So flying point. Next slide summarizes the differences. Much the same as the others. We've got feeder points coming in from the north to manage the transitions. I'll point out one little technical thing here. These two lines leading to the same point, this is what's called a required navigation performance. This just gives you an idea. If we need to design a path that follows an exact curve, we can do that. It's more difficult for some airplanes. It requires more advanced avionics in the aircraft. So this is something that it is in our toolbox to be able to fly an exact path versus sort of turning a corner. The additional waypoints, they are going to help us give that consistent path, the noise. The reduced noise footprint should occur over Sebastopol because we're keeping airplanes that are coming from the north further from the airport, higher and descending at a continuous rate. And the straight in, we don't have a lot of flexibility in where we place the path, but we are managing how you get onto that final path. So I've covered the different approaches to the runways that we've looked at. And now I'm just going to touch briefly on the departures. So if we go to the next slide. We've talked about this one as being in the early stages. It was sort of brought out, the redhead departure, mentioning that the aircraft pilots have in the cockpit. This is what they look at. Out to 500 feet, and then they turn. They turn in order to meet one of these 2 points, depending on whether they're departing north or south. And what we see here is that the focus in this particular design, from the FAA's perspective, looks like it was more based on how am I going to get airplanes lined up and into my high-level flow versus what is the impact going to be on the maneuvering down low. And this is what we're going to address. Those turn points at 500 feet are not a point over the ground. They are a point where the airplane happens to get to 500 feet. And if on departure, I happen to not have a lot of passengers or a lot of cargo, or I just want to fly like a cowboy, I can fly as steeply as possible in the departure, and I could reach 500 feet at the end of the runway. Or if it's a hot day and there's lots of people in the airplane and it's a heavily loaded airplane, I could be a mile or more off the end of the runway before I reach 500 feet. So this variation will occur as well. I'm on a runway heading. So as I depart, if the wind's blowing from the east or west and I'm departing to the north, I'm going to drift off that line. I will not fly a specific path. These are some of the things that we can work with the FAA. So some of the proposed modifications, and again, we'll be coming back to you to look at what's the best way to manage the noise in the area. We can devise procedures that have a specific track over the ground to a specific point at an altitude before they turn. So we can add these to the procedures. And I think we're somewhat hopeful that because it doesn't affect the other part, which was apparently the key focus to the FAA in getting airplanes into the en route, that we should be successful in making these kinds of suggestions. So just if you go to the next slide, summarizing what it might look like over the ground, this is notional. At 500 feet, the aircraft might be here. It might be at the end of the runway. It might be out here. Again, for all of these different spots. So really, you're going to get a lot of variation. And with high power settings at low altitude and banking, yes, you're going to get the biggest noise footprint that you could probably have, much larger on departure than arrival when you're using near idle power settings in descent. So this is one that we really want to look into. And they're all trying to get down to one of these 2 points. And it's notable that this point down here, the minimum altitude is 3,400 feet above sea level. So it's still pretty low. You could depart and climb quite slowly if you chose to and get down here. So see, these are the things that we'll look at as we're looking at the departures. And I think that that part of it leads well into John coming back up and talking about the Part 150 and the noise aspects of this study.
So in the last fall, we did have a Q&A on Part 150. The FAA has said that we as an airport have the ability to ask them to fund a Part 150 study. We've analyzed that process, and there's 2 big factors as to why it's not something we're recommending doing. The first part is it's voluntary. We've communicated with our airline partners and other partners, and that feedback is consistent. If it's not published, we will not follow it. We need consistency and regularity in the cockpit. And out of the 150 study, it's all voluntary. So there's a lot of concern, doing a lot of effort, coming up with great ideas, and then nobody doing it. The next part is the Part 150, based on how the FAA looks at it, is it's really focused on the 65 decibel community noise equivalent level line around the airport. They don't look at the single events per se. They look at the overall daily noise impact from the airport in a 24-hour period, giving additional weight to evening and night flights. And most of that contour in 2038 falls on the airport. So next slide. So on this slide, this is the 2038 noise, community noise level. So it is, again, different from single event. That doesn't change what you hear when that one airplane goes over. If you have a sound decibel reader, you could hear a 90 decibel aircraft. This looks at that 24-hour period, and this was based off of our forecast to 2038. This teal line is the 65 decibel contour. The purple line is airport property. So we have a small area to the north, a larger area to the south that do come off of the airport. The plan looks at land use and compatibility of the homes in those areas. When we did the airport master plan in 2012, part of the conditions of the approval of it was to have a plan for homes within that contour, which we do. There's about 8 to 12 homes, depending on how that line shifts over time. And we have a plan to mitigate the noise at those specific homes. So with those 2 factors, it really was not going to be beneficial to the community as a whole. And we have impacts to the whole community, not just a specific neighborhood. And the procedure we're going through, having Cignus working through the FAA process to change the procedures, we will then get to a published procedure that goes into the cockpit. Next slide. So again, going over the land use conformance, and we still need the FAA to agree, and the procedural redesign does that because we're following specifically their process. And again, we want that change to benefit the entire community, not just the homes within that 65 decibel contour. Next slide. Which gets into the next part. It's great that we can get the FAA to do these procedures and hopefully get them to approve them in a timely fashion. But there's a second part. We need to educate the pilots. We need to encourage them to do it. And we need to kind of put some oomph behind it. We found with the change that was done when we extended the runway, pilots didn't like it. And it didn't matter what kind of push we gave to them. They're like, I don't like being lined up for a mountain, not being able to see the runway when I come out of a cloud. So I'm not going to use it. I'm going to follow the straight in. And we did all that work with a procedure that didn't benefit anybody. And with a fly quiet program, we'll take these procedures, put them into a document, come up with a noise abatement program that encourages pilots, both visual and instrument, to do it. We'll bring in more visual procedures. And that's also where we'll be getting into the helicopters. We have a lot of visual helicopter activity at the airport. These instrument procedures really don't address those, and we have to find another way to deal with them specifically. We've been working with them on some other procedures currently at the airport. Still have a bit more work to do on that. And that'll be a parallel process as we're working with the FAA. So we'll be building that concurrently. And when they get published, we want both of them to go into place at the same time. Some of the programs airports have done, they have a scorecard. How did that operator do? And they post that on their website. This airline got a D this month. And we can potentially use that as a way to shame an operator, use the procedures. And in those cases where the airport does this concurrently with these procedural changes, there's a lot of change from the pilots. And they have to go hand in hand, or all this effort doesn't really change much. And with that, next slide. That concludes the presentation portion, and we'll be going into the workshop portion. So I want to thank everybody that's participated by Zoom. Our next steps is to have our open comment period until the 20th. So again, there's these cards, take these with you, scan that, give us your questions up until the 20th. We will record all of those comments. We will respond to all those comments, and we'll adjust where we can the procedures we presented to you tonight. Then we'll put that together as a package. We have to go back to the Board of Supervisors. We're hoping around the end of first quarter to approve the next phase of the contract, which is the specific design package for SMIL to the FAA and the creation of the Fly Quiet program. And again, want to thank you everybody for coming tonight, and looking forward to talking to you in the workshop portion. And forgot to see if Supervisor Hopkins had any last comments.
The one thing that I just want to say is I really encourage you to go and take advantage of that court reporter. I love getting your emails. I love getting your text messages and phone calls, and I fielded a lot of them today, and I will always try to respond. But if you don't talk to that court reporter, it is not part of the official record and part of the official process that is being moved forward by our consultants. So please, please, please go make your voice heard. Thank you for being here. And the other question that I just wanted to quickly clarify, I may have missed you covering it, but the two different runways actually correspond more or less to commercial and private aircraft. Is that correct?
So we do have two runways at the airport. Our primary runway is runway 1432, and that's set by magnetic heading. And that's our 6,000-foot runway, predominantly used by the corporate jets, the airlines. And then runway 220, it's about 800 feet shorter and narrower. The smaller airlines could use it. It's not one that they like to use. So when we were doing the runway repairs, some airline operators chose not to use it. So it's really not a preferred runway. CAL FIRE does use it a lot, but that's all visual. Hopefully I can cover it all.
Yeah, no. I just wanted to clarify that because I think it's important when you're looking at those diagrams that you're thinking about the types of planes who are going to be utilizing the different runways. And I don't know if that was kind of called out quite expressly, but I wanted to share that information with you because I found it helpful to think of, oh, that's the commercial runway where you see the bigger jets, like the type that I would take to go to San Diego or Seattle, right? Versus the smaller planes. So thank you all so much for coming. Thank you for an excellent presentation, and please go make your voices heard with that court reporter. Take care, everyone. Oh, and if you have any county complaints, I'll hang out in here. So like potholes, permits, that kind of thing, you know who to call.